Good afternoon to one and all. I'm R.V. Karan, Assistant Professor, Department of Mechanical Engineering, Chevrolet Engineering College. Today, in this video lecture, I'm going to explain the types of steering gear mechanisms. We got two types of steering gear mechanisms, that is Ackermann's steering gear mechanism and the Davies steering gear mechanism. And this is my 15th lecture regarding to the subject kinematics of machinery. In the previous classes, we have studied about the functions of steering gear system and what are the needs of the steering gear system. And today I am going to explain you about the different types of steering gear mechanisms. And in that, first one is the Ackermann's steering gear mechanism. Second one is the Davies steering gear mechanism. And in these two types of steering gear mechanisms, out of these, Ackermann's steering gear mechanism is almostly universally used because of its simplicity. So the simple structure in the Ackermann's steering gear mechanism results in the widely used steering gear mechanism. So let's see the explanation from the slides. So in these steering gear mechanisms, we have already seen that for perfect steering, we must always have an instantaneous center, that is capital I, above which all the wheels must be rotated. So these wheels must be, that is in the front axle and the back axle wheels have to be rotated, and it is about the connected to the instantaneous center in which it is rotated. For this purpose, inner wheel has to turn more than the outer wheel. So that is in this connection to the instantaneous center, the inner wheel has to turn more than the outer wheel. To achieve these conditions, two types of mechanisms have been devised. That is, two types of mechanisms have been classified regarding to these steering gear mechanisms. The first one is the Ackermann's steering gear mechanism. So in this Ackermann's steering gear mechanism, you can see this is the front axle of positions A and B. So in the AB positions, it is the front axle and the front wheels. So L and M are the two front wheels here, in which it consists is stub axle. So it consists of the stub axle, and the distance between the two axial points, that is the A and B, is considered as small c, and the distance between two axles, that is the front axle and the back axle, must be taken as small b, and the minute angle positions of the internal axle is taken as alpha in both the directions, that is in the right side condition and the left side conditions. These two conditions has to be taken as alpha. And the distance between the two wheels, the distance between the two wheels can be taken as small a for this condition of the straight drive. When the automobile is turning to the right side of it, so when it is turning the right side, so the stub axle is used to move in the right side end, and it is turned to be have a position of angle theta. So the inner circle has to be more accurate than the outer circle. Here you can see it in the picture. The outer wheel angle is phi and the inner wheel angle is theta to the instantaneous center. So here we are taking it as alpha plus theta angle. The angle is alpha plus theta. And for the stub axle and the straight line motion, we are taking it as alpha minus phi. Alpha minus phi. So alpha is the vacant angle here in the two axle minimum axle position. For the right side drive to the instantaneous center of the automobile. So these Ackermann's steering gear mechanism consists of crosslink CD connected to the short axles AL and BM. So that is AL and BM are the short axles and CD is the cross link attached to it. So this is the CD is the short link attached to the cross link BM and AL of the front two wheels through the short arms AC and BD forming bell crank levers. So AC and BD it forms the bell crank lever LAC and MBD. So that is the bell crank levers are the LAC and MBD. So it is the main structure, but is the combined short structure and it consists of the two levers. That is the bell crank levers LAC and BDM. That is MBD. When the wheel is running straight, but when the automobile is running straight, the wheels also is to be running straight. And the crosslink CD is parallel to AB. So these AB is always parallel to this CD position when the automobile is running in the straight direction. The short arms AC and BD both make angle alpha to the horizontal axis of the chassis. So the AC and BD makes an angle to the horizontal axis, that is to the exact. And in order to satisfy these fundamental equation for correct steering, the link AC and BD are suitably proportioned and angle alpha is suitably selected. So for constructing the equal angles, we are taking it as two alphas. That is, all two angles are taking as same position. That is alpha and alpha. That is in the from the horizontal position of the vehicle. We are taking the angle. Next, for correct steering, so we have already derived this formula. That is for correct steering, cot phi minus cos theta. That is the theta and phi angles to be taken as C by B for the correct steering of measurement. So for the correct steering, it is used to be taken as C by B. The angles phi and theta are shown in the figure. And the value of C by B lies between 0.4 and 0.5. Generally, it is taken as 0.455. And the value of cot phi minus cot theta corresponding to the positions when steering is in the correct position. So these corresponds to the when the steering is in the correct position. And in fact, there are three values of theta which gives the correct steering of the vehicle. First one is the while turning to the right side position. So it is to be insisted that when the automobile is running to or turning to its right position, and second one, when the automobile is turning to its left position. So when the automobile is turning to its left position, and last one, it is turning running straight position. So these are the three positions or three values of theta, which gives the correct steering of the vehicle. So when the vehicle moves in the right side portion, and when the vehicle moves in the left side turning, and when the vehicle moves in the straight position. So by deriving in the three positions, tan alpha is taken as, so tan alpha is equal to sin phi minus sin theta divided by cos phi plus cos theta minus 2. So this is the variable consideration of these three types of three values considering correct steering of a vehicle. The values of angles phi and theta to be taken in this equation are those found for correct steering. So for correct steering, phi and theta values are also taken as values. And further, when the value of angle theta is known, the length of the track arm can easily be determined. So it can easily be determined by its position of the